Okay, so we've gone and we've done our drift correction and our latitude correction for the 27th. And now you're going to go have to do the same thing for the 28th, the 29th, and the 30th. So you just follow the same procedure. I won't lie that Geosoft has given a script. So you can see here on the left-hand side, I clicked on this green triangle and I went to these three dots. I went inside of the sample data and you can see this load CG5 and I went open. And so this is a script that automates this. And you can click on edit script. I can see there. So there was quite a bit that, well, not quite a bit, the location files over at the top here. You'll see on the original script, it says it's in the D drive, but on my computer, it's in a completely different place. So you have to go and edit this. And I can see I've left out some places and it was giving me some errors and I didn't feel like fighting with it. So I'm sure all of you are cleverer than me and can go figure this out, but I don't have enough time right now. Scripts are amazing. So, I mean, I've only used it a little bit, but you can literally, when you're repeating something often enough, you can record a script so it picks up what you're doing. It then puts it into script format for you, so you're not actually having to code, and then you can run the script. So, I mean, it is phenomenal. I encourage you to use it, but I'm not going to use it right now. So I have loaded already the 28th, 29th, and 30th. The next step is to put it all into one master database. And so how you would do that, I'm going to just open up the 27th here, and I'm going to go gravity merge with master database. So, sorry, I'm just going to start on the 27th. And I'm going to create a merged database. So I'm going to call my master 2 because I've done it already. And it's going to take all of this, you can see, all the way up to your drift latitude corrected data and put it into this master database. And this is where it's very important that you make sure that all of these have the same headings. I mean, this is data in perfect format, but if you've got different dates, you need to make sure all the headings are exactly the same, else it's not going to merge it properly. So you click OK. It's going to create a new database for you, and you can see here this is the master 2 database. It's got all of this information going along all the way to the end here, and so you're going to have to repeat it again. Merge. You're going to do the same with the 28th. Again, you desperately need to make sure your headings are all the same. Click OK. Do you want to add it on because data already exists? You say yes, it's going to add it on. It's not going to replace data, and you just keep going. So I suppose I'm going to do it here to all of them. Yes. And then the last one, merge, was the 30th. Okay. And again, you could create a script for that if it was, if you had way more than just 4 days worth of data. I'm just going to close the stuff in the background so it's not taking up too much space. Okay. So we've got our master database here. So let's see what the next step is. Oh, and that looks disturbing. Wow, I have stars. So that makes me worried that I have maybe not done all the corrections. Thought I hadn't. So maybe I haven't done all my gravity corrections here. So a good way of checking it. So stars are not a good thing. So you can see I haven't done the corrections. Let's check which date. For the 30th. Okay, so I'm going to jump over quickly to my other database, the one that I was using earlier today, which should have everything done. But let's just check I've got all my gravity corrections. Looks about right. Let me just scroll. Yeah, that looks about right. The big thing I just want to do here is just edit my title because this is what I had earlier and it wasn't super easy. So this is drift and latitude corrected. Okay. And this earlier one here is actually latitude correction. You can see I was still learning stuff, so I didn't put my headings very well. Okay, so we've now got our drift corrected, and I'm going to quickly hide that one. So we've got our drift corrected data. So now we could actually start comparing our repeated values, because a good practice is to go and repeat stations you've measured within a loop as well as ones you've measured outside the loop or previous days. And so you can see here the next step in the menu is to click on the average repeats. So we're going to say selected lines. We actually only have one line in this database. The station channel is called station. Channels to average. So it's this gravity drift latitude correction. So we've done drift correction, latitude correction, so now we can compare values amongst the repeats, because the drift wouldn't have allowed, if we had not removed the drift, we couldn't compare the values because the values would have been different just because the instrument drifting. Okay, and we're going to calculate the mean. We're going to use line and station numbers to determine which ones we should repeat, just for higher accuracy. Average consecutive readings only. This one said that if you had made readings within a small interval, then it would average it, but we don't want that. We want to look over certain days. We don't want to reorder the station. It's just going to reorder the spreadsheet, and we're going to export it to this database, this average, master's average, and again, I'm going to put 2 because I've done this before. So it's literally just taking all of our repeat values and calculating the mean. And we click OK. And you can see here, it's going to give you some statistics on the screen here. So it says total number of stations, number of repeated stations, percentage of repeats 100%, total number of readings, number of repeat readings is this percentage repeat readings. So I feel this is a very high percentage of repeat readings, but maybe that's just me. But some very useful statistics to record. And you click OK. Again, you can see it's outputted here in my master average 2 database. And so this is the column we've been working with, this drift latitude correction. And now it's giving us the second one, the drift latitude correction mean. So it's taken all the repeat readings and created a mean. And you can see when we compare them, this is 2.8 and 2.81. There's another column that's actually hiding. So if you click on the heading here, go right click, list, and go this one here, gravity correction, this last one, mean repeat. Can I just say, so you're not confused, these last 2 were from the previous time I was using this database. So this mean repeat, click it. You can say, it's actually what it's doing is it's saying the mean minus the original, what is the difference? And you can see it's 0.01. So this column here is giving you an idea of how well your gravity column, that's drift and latitude corrected, fits in with the mean. And if I go through, all of mine are pretty small, but if they were high, it would give you a good idea of what your quality of your data. So let's just check. Yeah, so we got to this point. We've compared our average repeats. From what I remember, if you go back into the folder where you are working, which is here, it actually creates a log file. You can see this is the one down here. I've done it a few times. If I double click on it, it gives you an idea of project date, the line number, total number of stations, number of repeats, percentage of repeats. So this is stuff we saw before on that pop-up. But the nice thing here is the errors. So maximum repeat error, mean repeat error 0.01 is very good, and RMS error 0.05. So that's something you would put in your report. Okay,